I think we're all right. I can only, my iPad doesn't take a whole lot of memory. It doesn't have, it's the cheapest iPad you can get, so I can only post for like 10-minute videos, and if I get any bigger, it won't post. So I got to move pretty quick with this. If you read this, and I hope you understand this, but I'm going to go through this the best that I can and realize that something like this is going to be assessed on both group and individual. It's giving us a daily temperature of months. How many months in a year? 12, which already gives us our period, right? So it says estimate the amplitude, the period, and the phase shift, and the midline for this data right here. The very first thing I want to do is I want to find a max and a min. And it looks like that is my max, and this is my min. That max and min is going to do two things for me. It's going to find my midline and my amplitude. My midline is what? 33. What do I say? Do I say max minus min or max plus min? Max minus. For midline? Max plus. It's max plus min, which is 64.8 plus negative 7.8. So technically it's almost like subtracting anyway. And all of that divided by 2. All right. If I do that, I'm going to get 28.5. And that is going to be my K value, is 28.5. All right, I'm just going to highlight that, and I'm going to get my amplitude. My amplitude is the same thing, but I'm subtracting. So my amplitude is, again, my max, 64 plus 8, minus my min, minus a negative. So that's really adding 7.8 divided by 2. And if I do that, I get 36.3. So now I've already got two of those values, right? My period is decided by my B. Well, I have to change a period, right, that is 2 pi into a period of 12. So my B is literally going to be, right, 2 pi over 12, which is pi 6. All right? And I actually should have written that upside down. My B would really be the reciprocal. It would be 12 over 2 pi, which gives me 6 over pi. But when I plug it into an equation, it's the reciprocal with the formula that we have. All right? So I'm going to write everything that I've got so far, and I'll show you how to make a really good estimate of K. I say y equals 36.3 times the sine of pi over 6 is what I'm going to plug in, right? And then I've got x, and my h is going to go here, but I'm going to leave my h out for right now. I'm going to come over here and say plus 28.5. All right. I'm going to show you how to guess. And I did guess, and my guess was awesome when I put it in, all right? So I sounded like Trump just then. It's awesome. All right. So, oh shoot, I gotta post this and I'm gonna have a Trump reference in there. Please forgive me. No political, no judgment at all. So here I go. I've got 28.5 is my midline. And if you remember what sine does, sine starts in the middle and goes up. So I need to find out where my middle would be. My middle's about 28.5, so it's somewhere in here. Do you think it's closer to 33 or closer to 13.3? 33. I decided that I would guess that my middle was 3.8, and it's an amazing guess. I put that in. So I made my H 3.8, just because that was around the midline, and I could see the trend was going up.
To find your starting point, you have to find the H and the K. So as you can see, the H is pi halves. So you're going to put that...
This is going to be the most convoluted video ever. I hope it does help. All right, so look. I'm right here. And I'm going to plug it in. So here I go. It's going to be really hard to see this up there or on my film, but I'm going to plug in everything that I just did. So I'm going to say 36.3 times the sine of, and then I've got, what do I got? Pi divided by 6, begin parentheses, x minus 3.8, n parentheses, plus 28.5. And I graph it. And if it's good, and it does seem pretty good, it should go through those lines. So, and I can see, I'm going to show you on this video here if I can. Where is it at? There we go. That is pretty good, and it goes through those lines. And here's a really quick screenshot of the actual equation that's in there. And again, I'm going to graph it. All right, and this is for the rest of you guys to see as well. So I'm going to put it down here. Now, I made a guess at it with my 38.5. There it is. I made a guess at it. If I had guessed wrong, I would have just adjusted it right or left, right? If I wanted to adjust left, I would have gone higher numbers. If I wanted to adjust right, I would have gone with lower numbers, right? So I made an adjustment on it. But that equation worked really, really well, all right? This equation works really, really, really well. So I'm going to pause with that, all right? And I'm going to look on this, and I'm going to say a regression is what it asks for. So if my data is in there, and it is, I'm going to do a regression. I'm going to kind of angle it a little bit so people can see it up there as well, and hopefully you can see it on here. But I'm going to say it out loud. To get your regressions, you go the stat button, over to calculate, and if you hit up one, you're going to get a signed regression, and it puts it in there. And I get this really, really long equation. All right. And I'm going to pull up a completed worksheet pretty soon because I'm not going to write that in. All right. And then to put it in my calculator, I go to Y and I go down to Y2. What's the button I hit? Bars, statistics, equation, and it goes in. Now, I rounded it a little bit, but I'm going to use this other sheet that I already have written on. All right. And you can see the equation is right here. All right. The equation's right there. Cool. It shows up on this as well. All right. Now, I want to point something out to you guys. Do you guys need some more time to write it in? All right. I'll wait a little bit. But I had a lot of you guys saying this, and I won't move down here until I talk a little bit about what the question was. I had a couple people come up to me during our group activities, and they were like, how does this in here relate to this in here? Shouldn't my H be about the same, right? Shouldn't the values in here be about the same? And the correct answer is yes, they should be about the same, but they wrote them separately. All right? This equation doesn't separate your B from your H. All right? Your B is incorporated inside of this. Notice this has 0.5185x, and yours just has an x all by itself because we factored out the B, the pi over 6. I do want to point something out really quick. I'm actually going to go to my equation. All right, I'm going to quit. I'm going to say pi divided by 6, and pi divided by 6 is about 0.52. Isn't that what that is right there? Pi divided by 6 is about that, 0.52. So if you notice, the equation we made and the equation they made is about the same if I factor 0.5185x out. So look, here's what I did. If you divide this by 0.5185, it comes out and leaves me just x. And if you divide negative 1 and 976 thousandths by 0.5185, it comes negative 3.81. So is there a whole lot of difference between our equation and their equation? No, there's not. All right, they're almost exactly the same. Now, I'm going to check my time on this. Right? I'm going to check my time to see how much time, because it won't post very long. And I'm at 9 minutes. So I want to say something really quick. They're going to ask you something. And I'm going to push this up a little bit. And I want to show you how to do it. And I may have to pause this so I can post what I have online. They're going to say this. They're going to say, when do yours intersect with 10? So I'm gonna go right on here and make sure I can see it. And I'm just going to deal with ours. So I'm going to make sure that the second one is unhighlighted. So when I do that, you can see on there that the first one's highlighted. That'll be the only one that graphs, not the one that we had a regression formula from the calculator. I want to make sure you can see it on here too. I've made sure that only the first one right here is highlighted. It won't graph this one. All right. And then I'm going to go down to Y3. I'm going to set Y3 equal to 10. I want to make sure that one is highlighted. All right, so Y3 is equal to 10. And I'm going to show you guys the same thing. And I'm going to graph it on here so you can see it on here. And we can see that line going across my graph. All right. I'm going to come over here and show you what I did too. So if I set y is equal to 10, if I come down here, my y3 is equal to 10, right there, and I graph it, everything below that line is the months that had a lower average temperature than 10 degrees. All right? So from January, obviously that's February, to March, and well, not quite to March, it was lower than 10. Definitely not Phoenix, Arizona, right? And then if you look at it, it looks like the low temperatures from probably, I don't know, October, November, December, and I may have put an extra one. It might just be just November and December, also had lower than 10. So could I do a equation with a calculator? If I hit second calc intersect, I could find the exact point that the average went over. Do you guys remember how to do that? All right. I'm going to pause this because I think this video is probably just about the size that needs to be graphed or stopped at so it can go online.